Hi, this is Ms. Varka, and we're going to go through separation of a mixture pre-lab in order to prep you for the lab that you'll be doing this week. In the lab that you'll be working with, you will be putting together a mixture of salt and sand and iron after getting the masses of each one of those, and then you'll mix them together and then attempt to separate them using physical properties of the different components of that mixture. Okay? In our pre-lab today, I will go through several different things. I'll start with defining a mixture. I'll give you some examples of physical properties that can be used to separate the mixture, things that we can exploit. And then we'll talk about methods of separations. I'll also go through equations for percent mass, percent composition, which is mass percent composition, and the equation for percent yield. And I'll do a couple of examples using a mixture that we'll talk about of oil and vinegar. So let's start with our definition of a mixture. So when we define a mixture, that is actually the combination, a physical combination of two or more pure substances that retain their separate chemical identities and properties. So they would be physically combined, and they would still retain their properties. Okay, so that would be our definition for a mixture. The physical properties that we can exploit when we separate a mixture will include things like that's components, the different components' level of solubility, maybe their conductivity, maybe their magnetism, whether they're magnetic or not. Maybe we'll look at density so that they would separate in a density column, kind of like the oil and vinegar that we'll refer to in this example problem. We might separate by boiling point or melting point. So those are some of the things, the physical properties that we can use to separate out components of a mixture. Now, just a little background, most things that we deal with in our day-to-day life are actually mixtures. If they're not mixtures, they would be pure substances, and that would include atoms, molecules, things composed of just atoms, or things composed of a single type of molecule, like a sample of pure water. Okay. Next, let's talk about some methods of separation. So methods of separation, some very simple types might be literally taking things apart. So if you have, let's say that you have cereal and it has oatmeal, or sorry, it has raisins in it, and you don't like raisins, you might take the raisins out of it. But that is not a really good way to separate the types of things that we're talking about, so picking things apart. Some chemistry related types of separations would include filtration. So in filtration, we separate solids from liquid components by pouring through a filter. Another type of separation would be evaporation, where we have a solution that is a mixture of something that's dissolved, for example, in water. And if we evaporate the water away, then whatever was dissolved will remain behind as a solid. We can do decanting. That's what I'll be referring to with this oil and vinegar separation method. Decanting is a method where you have a mixture and you allow them to separate based on density, and then you pour the one that's on the top off. In this case, in decanting, we'll imagine pouring the oil off from the top of the vinegar after it separates. Yeah, another type is crystallization. So if you have a mixture of different substances in solution and they will crystallize out in cooling, then at different temperatures, your different types of crystals will come out of solution and form a solid crystal. Also dissolving in a solvent. So if we have something that dissolves in water and something else that doesn't dissolve in water, if we add water to that mixture, then what doesn't dissolve won't go into solution, but what does will. So that's an important method of separation. All right, next let's look at our equation for mass percent composition. I'll make sure that you can see that clearly. You're going to be asked for that in the pre-lab. So if we have mass percent composition, if we want to find the percent of any component we take the mass of that component and divide it by the total mass of the mixture. And we take that times 100 to find the mass of the component. And then we do that with the next component. And if there's an additional component with that one. We're going to use this equation for our practice problem in the pre-lab that is separating a sample of oil and vinegar that have been pre-weighed, mixed together, and then we're going to work with a mass composition for the original mixture and then talk about percent yield for that. Okay, so up to this point, we have talked about all of the first 4 questions on your pre-lab. Now let's look at question number 5. Question number 5, we're solving for the mass percent composition of a mixture that we make from a sample of 21.37 grams of oil and 16.83 grams of vinegar. To solve for the mass percent, we're going to look back over here at our equation for mass percent composition. And we can see that if we take the mass of the component divided by the total mass of the mixture, we're going to then take that times 100 and get our percent of that particular component. So our 2 components are oil and vinegar. So I'll just set this up so that I can solve for those separately. And we can see that we need a total value for the number of grams of oil with vinegar. So when we add 21.37 grams with 16.83 grams, that's the value that we'll get on the bottom for the total mass. So for that total mass, we get 38.20 grams. That's our total mass of the mixture. So we can use that for the vinegar as well. We're going to take the original mass of the oil, 21.37 grams oil, and divide by the 38.20. We'll take that times 100 to get our percent composition of oil. For the vinegar, we'll take 16.83 grams of vinegar divided by the total mass of the oil and the vinegar and take that times 100 to get our value. So if we put these into our calculator and come up with a value, that gives us 55.94% oil. And then when we calculate the value for the vinegar, we get 44.06% vinegar. So for our original mixture, we have a composition of this amount of oil and this amount of vinegar. Okay, so with these values of percent of oil and percent of vinegar from the original mixture, you're going to use this method when you find the initial masses of your salt, sand, and iron and come up with their original percent of the mixture. So you'll have to have a total and you'll have to have the masses for each of those. All right, the next part of the pre-lab questions is we take this mixture and we mix it up. Maybe we have it in some kind of a container. We seal the top, we mix it up, and then we allow it to settle. Okay, so this mixture of oil and vinegar. After the oil and vinegar settle, we use a separation technique called decanting, which is we take the container and we pour the oil off of the oil layer off of the vinegar layer. And we can get some of the oil off. It's not a perfect method of separation, but our results for that are over here on this board. So after decanting, we take the mass of the oil, we find the mass of the oil, it's 20.03 grams, and we have 16.99 grams of the vinegar recovered. We want to find the percent yield for the oil and the vinegar. So if our percent yield uses that equation that says percent yield is the actual yield divided by the theoretical yield. I'll take it back over here. Okay. So percent yield right here. The equation for percent yield is the actual yield divided by the theoretical yield times 100. So in the case of the oil and vinegar, the actual yield is what we had decanted of the oil divided by what we started with in terms of the mass of the oil. We'll do two of these. The second one will be how much was yielded of the vinegar after separation divided by the starting amount of the vinegar. And then we'll take those times 100. So let's roll back over here and work through our math. So after decanting the 20.03 grams of oil, we want to find the percent yield for the oil. So once again, our oil, we'll take what the actual yield was when we separated and divide it by the mass of oil that we started with, which if we look over at that original value, that was 21.37 grams. And we'll take that times 100. So we run the math on that, and we can see that we are less than 100% for our yield here. And our calculation shows that we have 93.7% yield for oil. Okay. So we didn't get back all of the oil that we put into the mixture, but that's okay, because sometimes with separations, we're definitely not going to have perfect separations occurring. Let's do the same with the vinegar. We were able to get a mass of 16.98 grams for the sample of vinegar after separation. We'll compare that to our original vinegar mass, which is 16.83 grams of vinegar. And we'll take that times 100 after we do the after we divide. That's going to yield, we can see that this value is greater than what we ended up with versus what we started with. And we can kind of guess that maybe some of the oil stayed in the vinegar layer, but we're going to do our calculation saying, okay, this is what we got for the vinegar. And it is actually over 100% yield for the vinegar. And it doesn't mean that somehow we came up with more vinegar than we started with. Typically, when we end up with a percent yield that's high, that means that we have something contaminating that sample. So in this case, we might think that perhaps the oil is contaminating the sample of vinegar. Our last piece then is to find the overall percent yield of the liquids in this mixture. Okay, the last piece for your pre-lab is, well, the second to last question, is find the overall percent yield for the liquids in this mixture. So we're going to use a variation for the percent yield equation, where before we had percent yield is actual yield over theoretical yield times 100. If we're looking at our overall yield, we want to look at the recovered yield, so the amount that we have recovered for the liquids in this oil vinegar example, divided by the mass of the original mixture, and then take that times 100. So if we were to look at our total mass from the previous problem, we would come up with 37.01 grams of oil and vinegar. And this is just adding the recovered oil mass with the recovered vinegar mass. We're going to divide that by our original total mass, which was a mass of 38.20 grams, if you look back at what we were working with before. This was the total original mixture mass. We're going to divide and then take that times 100 to get an overall percent yield. In this case, that's a 96.9% yield. Which means that we didn't fully recover all of the mass that we were working with. But sometimes we end up with percent yields that are greater than 100, which would mean that somehow what was recovered is contaminated with some other substance, and that's making the mass greater than it would be otherwise. The last piece that you're being asked about for this pre-lab is, the question is, how would you anticipate the separation of a mixture of salt, sand, and iron would be different from the separation of the oil and vinegar that I described in this pre-lab? So I'm not going to give you the answers to this question. This is a thinking question. You're supposed to think through how would making a mixture of sand, salt, and iron be different when you have the challenge of separating that mixture than the mixture of oil and vinegar from this. Thanks.